of that learning over time. Okay, so let's take a second and really think about what's happening in the brain and body when we do mental training or visualization. In fact, we can do a little experiment right now that is not unlike many of the classic experiments looking at what's happening in the brain and body during mental training and visualization, in which I just ask you to close your eyes and imagine a yellow cube. Okay? And next to that yellow cube is a red rose. And perhaps I also ask you to float or fly up above the cube and the rose and look at them from the top down. And then I tell you to fly back around and land behind those and look at them from the perspective of behind that yellow cube and that red rose. Okay. Now, what the data tell us is that most people will be able to do that. Most of you will be able to do that to some degree or another, regardless of your attention span, whether or not you have ADHD or not. Most of you will be able to do that to some degree or another. We also know from neuroimaging studies in which people are placed into a functional magnetic resonance imaging scanner that during the sort of visualization you just did or that I described, that your visual cortex and associated areas, quote unquote, light up. They become very active in similar but not identical ways to how they would light up and be activated were you to actually look at a yellow cube and a red rose on a screen and perhaps fly above them, virtually of course, and land behind them, virtually of course. Or if you were to actually look at a yellow cube and red rose in the real world, right in front of you on a table, then get up on your tippy toes and look down at them from the top and then walk around the table and look at them from the other side. So there is some degree of what we call perceptual equivalence between real world experiences, digital experiences, and imagined, meaning with our eyes closed, just in our mind's eye experiences. This is true not just of vision and what we call the visual domain, but also the auditory domain. Okay, so for instance, I could play for you a short motif of a song. Let's just pick something that I think most people know. Goodness, I'm a terrible musician and even worse singer. But let's just take the opening to AC/DC's Back in Black, right? I think I can do that one. It's like, dun, 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 dun. Okay, got it. That's the actual sound, although admittedly a dreadful version of the great AC/DC song Back in Black. But now I ask you to close your eyes, or you could keep them open and just imagine that dun, 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 okay? Or for instance, I place you in a quiet room, so you close your eyes, and I ask you to imagine the opening to AC/DC's Black in Black, but I ask you to pause it halfway through. What you would find again is that most people, somewhere between 90 and 95% of people, would be able to do all the sorts of things I described, right? Cube and rose, AC/DC Back in Black. Even a somatosensory task. I imagine you to imagine what it's like to touch felt or to touch chinchilla hair or something like that. A chinchilla's hair, ideally a live chinchilla, sitting still. Those little critters move really, really fast, but they have very, very soft hair, high hair density, so soft. Okay, most people can do that. About 5 to 15% of people are less able to do that. And there's a small percentage of people in that 5 to 15% that simply cannot do it at all, that just cannot visualize well. And we'll talk later about these people. They have what's called aphantasia, an inability to mentally visualize. But most people are actually pretty good at visualizing things when they are told what to visualize. And this is a really key point, and if what they are told to visualize is very simple and the whole visualization is quite brief, lasting on the order of about 15 seconds to generate the visualization in the auditory or in the visual aspect of one's mind's eye or ear, if you will, and if it's repeated over and over. What's far harder for everybody to do, and in fact, what most people simply cannot do, is imagine long extended scenes and stories in their mind that go on for minutes and minutes and involve a lot of different sensory stimuli. This is a really key point. In fact, as we start to home in on ideal mental training and visualization protocols, I'd like to establish this as the first principle of mental training and visualization, which is that if you are going to use mental training and visualization to its best effect in order to engage neuroplasticity and learning, you need to keep those visualizations quite brief, really on the order of about 15 to 20 seconds or so, and pretty darn sparse, meaning not including a lot of elaborate visualization, not including a lot of sequences of motor steps. What I mean are motor sequences, if you're trying to learn something in terms of physical movement, or visual sequences or auditory sequences, if you're trying to learn things in terms of music or dance, etc., that can be completed and repeated in 15 seconds or less. Now, later I'll give you a couple of specific examples, but if you want to use mental training and visualization, understand this is the key first principle. They have to be very short visualizations that you can repeat over and over and over again with a high degree of accuracy. So you don't want to embark on a mental training and visualization paradigm in which it involves a lot of elaborate stimuli and you have to think really hard and work really hard, even if you're in that category of people who can do mental visualization pretty naturally and easily. Now, if you're somebody who can't do mental visualization, in fact, if you're somebody who has full-blown aphantasia or the inability to mentally visualize, well, then it's especially important that you make those mental trainings and visualizations really brief and very, very simple. Now, in order to develop the best mental training and visualization protocols for you, let's go a little bit deeper into what the research says about mental visualization. Now, the classic work on mental visualization really hinges on a number of different researchers and their work, but in particular, Roger Shepard, who did this work at Stanford, and Stephen Kosslyn, who's now at Harvard. There are, of course, others in the field, but it's really the work of Shepard and Kosslyn that lay the foundation for our understanding of what happens in the brain when we mentally visualize something. Shepard did these incredible experiments in which he had students mentally visualize simple objects, like a square, like a triangle, and he measured how long it took them to do that. Now, of course, at the time when he did these experiments, there were no sophisticated brain imaging devices and machines like fMRI. However, everything I'm about to describe has been later confirmed using things like fMRI. What Shepard did and what he found is that if people were told to visualize very simple objects, they did it pretty quickly. However, if they were told to visualize more complex objects, or importantly, to rotate those objects in their mind's eye, well, then it took longer for them to perform those mental visualizations. Now, many of you might think, duh, if I have to just imagine a triangle or a cube, that's going to be very easy and very fast. Whereas if I have to rotate that triangle or cube in my mind's eye, that's going to take more time. And indeed, that is somewhat of a duh, except, and this is so very important, except that what Shepard and his colleagues found is that how long it takes somebody to generate and rotate a given visual image scales directly with the complexity of that image. In fact, Kosslyn did some experiments, I think illustrate this even better. And here's the experiment. I love this experiment. I think you'll love it too, because it illustrates something so fundamentally important about how our brains work, not just for sake of mental training and visualization, but just how our brains work at all. He showed people a picture of a map. So a map drawn on a piece of paper. This was a map of an island. It included things like a loading dock for some boats. It had a location for getting food on the island. It had some trees. It had some other small landmarks drawn out. And people looked at this and memorized it. Or in other experiments, they just had people imagine this island and the location of these different landmarks on the island. So it didn't really matter which. But then he had people imagine moving or walking from one location on the island to another. So they'd say, okay, you're at the loading dock, now move to the restaurant. Okay, you're at the restaurant, now move to the palm tree. You're on the north shore of the island, now go around the side of the island clockwise to arrive at the bay on the southwest corner, this sort of thing. What Kosslyn found was absolutely incredible. What he found was that the amount of time that it takes people to move from one location on the map to another scaled linearly, directly with the actual physical location between those objects on the map. So for those of you that can understand or intuit the importance of what Shepard and Kosslyn showed, great. I'm guessing, however, that for most people out there, you're still grasping it like, okay, interesting. You know, how things happen in the real world dictates how they happen in our mind's eye. But I want to make sure that I really nail home the importance of this for everybody. The importance of this is that when we look at something in the real world, so if I look at the pen in front of me, I'm holding up my pen. For those of you that are listening, just holding up my pen in front of me. I move it to the right and back and forth. What's happening is I'm activating or I'm triggering the electrical activity of neurons, which we can think of kind of as pixels in my eye. Okay, so it's leftward to rightward motion for me and back and forth. And those are getting activated and they're sending signals up to my visual cortex. And that information is processed at a given speed. What the visualization experiments that Shepard and Coslin and others did show is that the processing speed of imagined experiences is exactly the same as the processing speed of real experiences. And the spatial relationship between imagined and real experiences is exactly the same as well. Put simply, when we imagine something in our mind's eye or mind's ear, we are imagining the real thing happening. And when I say the real thing, it's not the obvious real thing. Of course, if you're imagining something, that's the thing you're imagining. What I mean is that your brain at the level of neurons is behaving exactly the same way. And this needn't have been the case, okay? There could have been a result, for instance, that if people were asked to visualize a cube and rotate it from, flip it from top to bottom, okay? So put the top that's upward on a table now down on the table and so forth, or to migrate around the island, counterclockwise, going from, the northern coast all the way down to the southern coast clockwise and then back up to the northern coast, that they could have just done it really quickly, like all in 1 second. But that's not what happens. They always match the speed at which they do things in their mind's eye to the same speed that they do them in the real world. So in telling you this, what I'm saying is that mental visualization at the neural level is identical to real world events. So when you've heard that when we imagine something, it's identical in terms of our brain's experience of it and our body's experience of it, as when we actually experience something, that is true at the neural level. However, when it comes to learning and improving performance in the cognitive or physical domain, they are not equivalent. So this is the second principle of mental training and visualization. As you recall, the first principle of mental training and visualization was that in order to make it effective, it needs to be very brief and very simple and repeated over and over again. The second principle of mental training and visualization is that while yes, mental training and visualization recaptures the same patterns of neural firing in the exact same ways as real-world behavior and thinking, it is not as effective as real-world behavior and thinking. In other words, if you want to learn something, the ideal situation is to combine real training in the physical world with mental training. And I'll talk about exactly how to do that and in what ratios a little bit later. Now, there's a really incredible set of experiments that illustrate why it is that mental training and visualization can be extremely effective, but that it's always going to be most effective when combined with real-world training and experiences. The experiments that I'm talking about involve the use of what are called bistable images or impossible figures. Now, some of you are probably familiar with impossible figures. These are figures or objects that when you look at them, they have these odd features, like you're not sure where they stop and where they start or where they end. One good example would be the so-called Mobius strip. The Mobius strip is literally a strip or a line that is contiguous. It goes up and it loops around and then it curves around and then it goes back and it just continues and continues. And when you look at it, you can never really tell where it starts and where it stops because it doesn't have any of the features that allow you to see what's the front and what's the back in any kind of stable way. Another example of an impossible figure would be, a little set of cubes that look like they're coming out toward you, maybe with a little bend in them, going up at a right angle, perhaps. But then if you look at it a little bit longer, that little piece that's facing up looks like it's in front. And you can't really tell what's in front and what's in back. And so it's called an impossible figure because you don't really know how to frame it in your mind to tell what's closer to you and what's further apart. Bistable images are somewhat similar, although different in the sense that they typically are simple silhouettes. So for instance, the faces vases bistable image is perhaps the most famous of these, where you look at this image, it's very simple and it looks like two vases. But then you look at it a little bit longer and you realize that you're looking at the side angle or the profile of two faces looking at one another. And when you see those two faces looking at one another, you can't see the vases at the same time, but then if you decide to see the vases again, you can see the vases again, but the faces disappear. So it's bistable, meaning that you can't see the faces and vases at the same time. And impossible figures and bistable images are capturing the fact that your visual cortex and some of the associated areas that compute visual scenes in your world are essentially trying to recreate whatever it is that's out in front of them. And that's effectively what your visual system does. It's very good at recreating visual images in your brain, in your mind's eye. Because if you think about it, even with your eyes open, your brain is just creating an abstract representation of what it thinks is out there. But that when it comes to assigning an identity to something like, oh, that's a face, or oh, that's a vase, that is constrained by different neural circuits, by different areas of the brain. And somehow those circuits can't be coactive. We cannot see the faces and the vases at exactly the same time. We can switch back and forth really quickly, just as we can switch back and forth really quickly when we're looking at the impossible figure and think, okay, that's the front of it, that's the back. No, wait, that's the back, that's the front. And it's going back and forth, but we can't see them both at the same time. No one can see them both at the same time. Okay? We know this from brain imaging studies. Now, impossible figures and bistable images can be seen, right? You could look them up right now on your phone or computer, or I could show you pictures of them on paper right in front of you. And you can do these sorts of perceptual experiments of telling people, look at the face, look at the vase, look at the front of the cube, and now make it at the back of the cube. And they can do this somewhat deliberately. However, and this is, I think, so very interesting to understanding how mental training and visualization does and does not support real-world learning. If you try to imagine a bistable image, you can't do it. In fact, no one can do it until they do something else. Okay, so for those of you that are saying, wait, I can do it. I can do faces, vases in my mind's eye. I promise you that the neuroimaging disputes your belief, okay, and supports the idea that we can see real-world bistable images. We can see real-world impossible figures, but when we try and imagine those in our mind's eye, we simply can't do it. We can't do the perceptual shift in our mind's eye. We can't switch back and forth between faces and vases. However, and I just have to chuckle because I think these experiments are so clever. If I have you trace or draw with a pen on a piece of paper an impossible figure or the faces, vases, bistable image, and then I ask you to imagine that bistable image or impossible figure and to switch back and forth, you are able to do it. So what that illustrates is that it's the combination of imagined and real world experiences, real motor movements, real perceptual experiences combined with motor movements, combined with what you imagine in your mind's eye that really gives you the most depth and flexibility over your mental visualization. And in doing so, we can really stamp down a third principle of mental training and visualization, which is that your mental training and visualization will be far more effective if you are performing the exact same or very similar mental and physical tasks in the real world. Okay, so first principle is mental training and visualization needs to be simple and brief and repeated. Second is that mental training and visualization is not a replacement for real world motor training or cognitive training. It's an augment. It's an addition that can really help. And the third principle of mental training and visualization is that you need to combine mental training and visualization with real world behaviors and experiences that are very, very similar. Now, as a brief, but I think really relevant aside, one of the things that also makes mental training and visualization more effective is when we assign cognitive labels to what's going on when we visualize. So what I mean is that people are much better at manipulating faces and vases in their mind's eye, of course, only once they've drawn them out physically with their hand, as I mentioned before, than they are manipulating abstract objects like impossible figures, in part because by labeling them faces and vases, people are able to capture a lot of other neural machinery that's related to faces and vases. In fact, we have entire brain areas on both sides of the brain devoted to the processing of faces, so-called fusiform face area. We have other areas in our brain that are involved in processing of 3D objects, but faces are of particular value. There's a value to understanding what a face is as opposed to a non-face, and there's a value to understanding what a particular face is. In fact, the simplest way to put this is that the human brain is, in many ways, a face recognition and expression of faces recognition machine. It, of course, does other things, but it is exceptionally good at that. Unless you're in a profession in which the relationships between 3D objects and your ability to manipulate them is exceedingly important, you're not going to have a lot of neural real estate specifically devoted to that. Some people will be better at it, some people will be worse. But when it comes to faces, unless you have a condition like prosopagnosia, which is an inability to recognize, say, famous faces, and distinguish them from non-famous faces, or if you have some sort of face recognition deficit, which about anywhere from 1 perhaps to 3% of people out there have. Okay, they're just terrible at recognizing faces. And by the way, there's about 0.5% of people out there that are what are called super recognizers that can recognize faces in a large crowd. They can recognize specific faces even from just partial profiles. By the way, these people are extremely valuable to security agencies, and security agencies are very good at finding these people. Machines are quickly getting better, or at least as good as super recognizers, but the best super recognizers are still better than the best AI and machine algorithms out there. But the point is that in your mind's eye, you are better able to manipulate specific objects or to see things more clearly and with more specificity when it has a label that you recognize from your real world experience, as opposed to abstract or fictional labels. Okay. Again, stamping home the idea that what you experience in the real world really serves to support your mental imagery, and therefore the key importance of experiencing and doing things in the real world and supporting that with mental training and visualization, and not just relying on mental training and visualization. And the tangent here that's a little bit of fun, and I don't think we've ever talked about before on this podcast, is that of UFOs, unidentified flying objects. There's a lot of people out there who think that they've seen UFOs. I guess technically they have, because a UFO is an identified flying object. And if it's unidentified, at least to them, then it is indeed a UFO. I guess the question is whether or not, or the dispute rather, is whether or not those UFOs are actually flown by aliens or controlled by aliens. I think that's where the dispute lies. But you can imagine how if somebody sees an object in their environment and decides, that's a UFO, okay? Remember these faces, vases, or these impossible figures? If they say, oh, that thing is a UFO as opposed to something else, they see, in other words, the face, not the vase. Well, that stamps it down as a memory in their visual system and related systems. And then in their mind's eye, they are seeing the UFO. They're not seeing the other thing that it could possibly be. Okay, so it's stamped down a very specific memory. So the point here is that mental training and visualization relies on not just the physical contours and the exact spatial profiles and the speed of movement of particular things that we experience in the real world. It also heavily depends on the cognitive labels and the decisions we make about the things that we see. And this will become very important as we build up toward our fourth principle of mental training and visualization, which is that our cognitive labels, that is what we decide is happening when we do mental training and visualization, turns out to be very important. Now, this is not simply to say that you can decide, okay, I want to learn how to play piano. And so I'm going to tell myself that a particular chord I imagine in my mind's eye is identical to the real world chord just because I decide it is. The brain doesn't work that way. It's not possible to just lie to yourself and learn better as a consequence of the lies you tell yourself. However, what this tells us is that it is very, very important that your mental training and visualization accurately recapitulate the real world training that you're doing. So if we are going to stamp down a fourth principle of effective mental training and visualization, based on what we know from the scientific literature, is that your mental training and visualization should assign labels to what you're doing that can be matched to real world training and experiences. Now, these can be somewhat abstract. So for instance, if you're trying to learn a particular aspect of the golf swing, okay, so let's say that you're working on your golf swing. It seems to be there are a lot of people out there working on their golf swing, and you're going to do some mental training and visualization in order to improve your golf swing. We already know, again, let's just march through them, that your mental training and visualization needs to be brief and simple. It needs to be the same, or in fact, it will be, we can say, the same as your real world golf swing. In other words, it will take you exactly the same amount of time to perform that golf swing in your mind's eye as it would in the real world. Incredible, right? Again, something that maybe is taking a little bit of time to sink in, but once it does, you're gonna be like, wow, the brain is really an incredible machine. And that third principle, that you still have to do golf swings in the real world, in addition to the mental training of golf swings. And fourth, that if you want that mental training and visualization to really improve your golf swing, you're going to have to name or apply an identity to the specific golf swing or aspect of the golf swing that you're practicing. So this could be abstract. You could call it mental training and visualization of golf swing 1A. And you could imagine in your mind's eye, the perfect golf swing over and over and over and over. But then when you're in the real world, you're also going to have to call that either out loud or just to yourself, golf swing 1A. okay, as opposed to a putt, which might be 1B. So naming and giving an identity to a real world skill and applying the same name or identity to the mental version of that, the visualization of that, can enhance the mental training and visualization in significant ways. So when we apply identities or names to these mental trainings and visualizations, and again, provided that they are brief and repeated and so on, we greatly enhance the amount of neural machinery in the brain and body that we are able to recruit when we go to perform those real world golf swings and golf putts. And here, just replace golf swing and golf putt with anything that you're trying to learn. You're able to recruit a lot more neural machinery and greatly increase the probability of proper execution. So before we go any further, I want to share with you a couple of incredible aspects of mental visualization that really can be harnessed and applied toward mental training and visualization. Okay, some of these were done by Roger Shepard and his graduate students and postdocs. Some were done by Steve Koslin and by others. What these experiments really show is that mental training and visualization is capturing many, many of the exact same features of real world behavior and perceptions. Not all of them, but many of them. So for instance, if I tell you to close your eyes and imagine a ceiling that has tiles that are black and white checkered tiles, one black tile, one white tile, for instance. We know based on experiments where we measure eye movements behind closed eyelids that people tend to move their eyes up when they are imagining things above them, such as a ceiling. Whereas if I tell you to imagine things down on the floor, like you're taking a hike and you're looking for rattlesnakes, actually just recently I experienced, because it's spring here in California, rattlesnake along a hiking trail. It's really quite beautiful, although I have to confess, I enjoyed keeping my distance. I don't like snakes very much. I don't dislike snakes, but I prefer not to interact with them unless I have to. If I have you imagine that rattlesnake, depending on your relationship or thoughts about rattlesnakes, a number of things will happen in your brain, of course. Activation of the limbic system or not, for instance. But what I know is that regardless of how you feel about snakes, most of you will move your eyes down when imagining a snake. Okay? It might be subtle, it might be fast, but statistically, that result shows up, as opposed to when I imagine or I ask you to imagine something above you. You tend to move your eyes up. In addition to that, if I tell you, for instance, to imagine an elephant and a mouse next to one another, you presumably have some real-world understanding about the relative sizes of elephants versus mice. Elephants generally are bigger than mice, thank goodness. Mice are smaller than elephants. If I ask you to tell me about the details of that mouse's face, so for instance, can you see its whiskers? The processing time required for you to do that is much longer than the processing time required if I say, tell me what the position of that elephant's trunk is. Now, why would that be so? Okay. The position of the elephant's trunk wasn't something that I told you. It wasn't dictated by me. It's in your mind's eye. Maybe you don't even know and you have to go searching for it. But what we do know is that if I tell you to look at a small object in your mind's eye versus a larger object, so for instance, the mouse versus the elephant, it takes longer for you to do that. In other words, just as with the map experiment, the distance between things on a map is conserved in your mind's eye as a linear relationship. It takes longer to go far distances between things on a map in your mind than it does to go shorter distances. It's also the case that it takes you longer to look at the details of a small object versus a large object. Because why? Because you are zooming in your mind's eye. Again, all of which speaks to the equivalence of mental imagery with real world imagery and perception. And as I mentioned earlier, and as we'll see in a moment, this also extends into the motor domain. It takes you longer to perform complex motor sequences in your mind's eye than it does simple motor sequences, just as it would in the real world. And if you're saying, of course, well then great. Then we've really underscored the point, which is that when you imagine things, it is not exactly the same, but it is very, very much the same as actually doing or perceiving those things in the real world. And the fifth principle of effective mental training and visualization is this notion of equivalence of mental imagery versus real-world perception and behavior. These are the experiments, as you recall, where if people are told to look for clouds in their mental visualization, they tend to look up. Or if they're looking for something on the floor, they tend to look down, even behind closed eyelids. Now, this can be applied toward building an especially effective mental training and visualization protocol if you deliberately move your eyes in the direction of the thing or things that you are trying to recapitulate in your mind, in your visualization, that is. You don't necessarily have to include this step, but mental training and visualization is going to be more effective if you do, because with consciously generated eye movements, again, even behind closed eyelids, you are bringing about more of the neural circuitry that one would experience if you were to perform that particular cognitive task or motor task in the real world, which, as I mentioned before in principle number 3, you need to be doing anyway, separately from your mental training and visualization. So what we're talking about here is thus far 5 principles of mental training and visualization that are well established from the scientific research literature. In fact, I haven't mentioned this quite yet, and I'll refer to some other references, but there's a wonderful systematic review of a large number of studies that have looked at mental training and visualization, what's effective, what's less effective, across a bunch of different disciplines that include education, medicine, music, psychology, and sports. We will provide a link to this paper in the show note captions, but the title of the paper is Best Practice for Motor Imagery, a systematic literature review on motor imagery training elements in 5 different disciplines. As the title suggests, it's mainly for motor imagery training, but it extends into music, which of course involves motor training and execution, but as well as education. This review establishes a number of different important things. I'm going to read off some of the key or highlight takeaways. For instance, I described principle 1 of effective mental training and visualization, which is that the visualization be brief and it be simple and it be repeated. You may ask how many times that very brief 5 to 15 second exercise of going through some routine should be repeated. Well, different studies have used different ranges of, let's call them repetitions in a given training session, but the number that seems to be most effective is somewhere between 50 and 75 repeats per session. That brings about the question of how long one should rest between each repeat. This gets a little tricky depending on what you're trying to do. Remember that we have this threshold of about 15 seconds for completion of the entire motor sequence. Let's say what you're trying to do, like a golf swing, takes you 5 seconds to imagine in your mind's eye. From the point where you, let's just say, have the ball on the tee, you bring the golf club up, you might reposition your feet just a little bit, that kind of little wiggle that golfers do, and then the swing. If that whole thing takes 5 seconds in your mind's eye and roughly 5 seconds in the real world, well, then you'd be able to repeat it, of course, 3 times in 15 seconds. That would be 1 repetition, even though you're doing it 3 times. So it's 1 15-second epoch, as it's sometimes called, EPOCH, epoch. And then you would rest for an approximately equivalent amount of time, 15 seconds or so, and then repeat. Then rest 15 seconds or so, and then repeat. Rest 15 seconds, and then repeat. Again, 3 golf swings within that 15 seconds, rest 15 seconds. 3 golf swings within that 15 seconds, rest 15 seconds. Truth told, these epochs and these rest periods do not need to be exact. You could imagine, for instance, that you get 3 repetitions of the swing within 14 seconds. Well, then do you do another one or do you wait until the end of that 15 seconds? I encourage you not to obsess too much about those sorts of points. Rather, you want to do as many repeats as you can in about a 15-second epoch, and then rest for about 15 seconds, and then repeat for a total of 50 to 75 repetitions, which might not sound like a lot to some of you, might sound like an awful lot to others of you. To me, it sounds like a lot. 50 repetitions of something and where you're trying to concentrate in your mind's eye on getting something accomplished over and over again in exactly the same way might seem like a lot. We know, based on the learning literature, that your ability to successfully perform something in the real world will lend itself to better performance of that thing in the imagined world within your mind's eye. That's also one of these sort of does. But if you're trying to get better at something that you've never performed before, you really should know that. The mental training and visualization is probably not the best augment to that real world training until you're able to perform it successfully in the real world at least some of the time. Mental training and visualization can be effective, however, at increasing the accuracy or the frequency at which you can do that real world behavior. So if normally you're only getting the correct swing or you're only hitting the golf ball correctly say 10% of the time, mental training and visualization can really help bring that number up. But it is important that you are able to successfully complete that motor task in the real world. Similarly, for performance of cognitive tasks, so say, for instance, speaking a new language. You might ask, well, gosh, what in the landscape of speaking a new language can be restricted to 5 to 15 seconds where I could repeat it anywhere from 1 to 3 times in a given epoch and then rest and then keep repeating 50 to 75 times? Well, there I would encourage you to pick something that you are able to do perhaps very slowly. So to speak a particular sentence, but with some challenge in getting the accent and the enunciation right, but you've completed it successfully before, and you want to get more smooth or more fluid with it. Likewise for playing piano or guitar, again, you have to translate to the specific cognitive and or motor activity that you are seeking to improve at. But those epochs lasting 5 to 15 seconds are really the cornerstone of an effective mental training and visualization practice. And the repeated nature of it, 50 to 75 repetitions in a given session, is also another cornerstone of an effective mental training and visualization practice. So says this review and some of the other papers that I'm going to get to in a few moments. Now, one of the other key components of a successful mental training and visualization practice is how often you perform that mental training and visualization practice. And again, a number of different studies have looked at this through a number of different lenses, meaning anywhere from 2 to 8 times per week. It does appear that performing these sessions anywhere from 3 to 5 times per week is going to be effective. We could perhaps even say most effective, because most of the let's just call it the strongest data really point to repeating these 50 to 75 trials of the same thing 3 to 5 times per week. So you can come up with a number that's reasonable for you to do consistently. And you might ask, do you have to continue to perform the mental training and visualization forever? And the good news is the answer to that question is no. It does seem that once you have what's called consolidated the motor performance or the cognitive performance of something, it can be further supported or reinforced, that is, consolidated in the neural circuits that are responsible for performing that mental or physical task. So in other words, once you are performing that cognitive or motor task in a way that's satisfactory or perhaps just improved, perhaps you're not 100%, but it's improved in the real world, you don't need to continue to do mental training and visualization to maintain that real world performance. So that's a good thing. In fact, the ideal situation would be then to pick a different sequence or thing that you're trying to learn and do mental training and visualization for that. I perhaps might have misspoke there, although I don't want to edit this out. I misspoke in the sense that, again, I said for the thing that you're trying to learn. Remember, mental training and visualization is going to be most effective for building up the number of accurate trials or your ability to do something with a greater frequency of something that you're already capable of doing or have done at least once in the real world. Okay? This is not to say that mental training and visualization can't be used to acquire new skills. It can in principle, but it has been shown to be most effective for enhancing the speed and the accuracy of skills that one has already demonstrated some degree of proficiency at in the real world. I think that's important to point out because we often hear mental training and visualization and this equivalence of perceptual and motor experiences in our mind's eye to the real world. And we think, oh, all we have to do is imagine doing something and we will get better at it. And unfortunately, that's not the case. The good news is, however, if you can do something once, even very slowly in the real world, and then you bring it to the mental imagery and visualization domain, you can get much faster at it in a way that really does translate back.